Hi and welcome. Data doesn't show us what's happening, it shows us why. We've looked at maps, but today we're moving into the math. We are performing a full linear regression analysis to ask the hard question. Is there a mathematical certainty between pollution and chronic disease in California? So by the end of this video, you know how to prove the science behind the toxic cocktail. So let's open up a new page and then we're gonna start by the first step in Tableau. So I'm dragging our first environmental drivers into the columns. So the first one is pollution burden. The second is groundwater threats. The third one is the PM 2.5. And then the last one is the solid waste. So these are our independent variables. So that's the X in our equation. So next for our rows, we add the health outcomes. We're gonna start by the cardiovascular disease, then asthma, and then low birth weight. So as you can see, Tableau immediately creates a matrix of 12 potential stories. Right now, they look like a single lines because the data is clumped together. We need to break that down to see the truth. So to see the relationship, we need to go deeper than just average. We need to see every individual story. So take California County to details. So the grain of data, every dot you see represents a specific community. So as the dots bloom across the grid, notice the distribution. So we're gonna just doing some edit by changing some colors and the shape of the dots. Maybe I'm gonna choose full dots, square or triangle. So whatever that works better for your Tableau when you present it. So this is explanatory data analysis. That's what's called EDA. So if you look at the PM 2.5 versus asthma plot, it's a tight upward climbing staircase. That's a direct hit. So other plots like a groundwater versus birth weight are more scattered, showing us where other factors may be at play. So we aren't just looking at chart, we're looking at the fingerprint of environmental inequality. So we can finally see the outliers, those points sitting high above the rest, representing the hotspots that need our attention most. So let's just edit the last one. And then now we're gonna go to activating the math, which is called the regression. Okay, good. So now for the proof, we're gonna go to the analytics pane and drag trend line onto the view, dropping it onto linear. So we can choose logarithmic, exponential, polynomial, power, but we're gonna choose linear because of the dots or the trend we have. So Tableau just calculated 12 linear regression using formula y equal a plus bx. A is our intercept, and the b is our coefficient that's called the slope. So the slope tells us exactly how much a health risk increases for every unit of pollution added. If the line goes up, the risk is real. We are no longer guessing, we are measuring the weight of the burden. So the most important part of this analysis is the hidden in the hover. When we look at the trend line, we see the R square and the p-value. In our study, the p-value is less than 0.001. In the world of statistics, that's the gold standard. It means there is less than 0.01% chance that these health outcome and pollution levels are connected by accident. This is statistical proof of environmental injustice. The link between this polluted and California's health crisis is mathematical and undeniable. So we've got from a map to a mathematical model. We prove that solid waste and groundwater through its rise, so that's the burden in our hearts and lungs. This is how we use the data to advocate for change. So this is for the video. Happy analyzing.